video, we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet, Volumes of Solids. I'll leave a link in the description below so you know how to access this free worksheet. Our first set of instructions are to find the volume of each figure, and we're going to be rounding to the nearest tenth. So diving into number 1, let's identify what kind of figure we have. Well, we have a triangular prism, where the base is a triangle and we could extend that in one direction to reach our full figure. So envision taking one of those triangles that's a base and either pulling it up, expanding that figure, or pushing it down, still expanding that figure just in a different direction. The bases are the same. We have a prism and it's a triangle base, so a triangular prism. Now, in order to calculate the volume of a prism as such, all we need to do is calculate the area of a base and multiply it by the overall height of the figure. So see, here is the area of one base, and then extending that up, here is that height. So let's go ahead and calculate that now. If you remember, the area of a triangle, since our base is a triangle, is the formula 1/2 the base times the height. Now, as to not confuse this, what we just talked about, base and height, this is the length of the bottom or the base of that triangle, and this h is the overall height of that triangle. So that calculates the area of our triangle, and then we're going to multiply the area by the length at which we extended that triangle, which I'll label as L. So now we're just going to fill all of this in to calculate our area. So 1/2 is a constant. That gets multiplied by the length of the base of our triangle. So our triangular base, the length of its base is, well, it's not labeled in this bottom triangle, but it is labeled up here as 5 yards. So that's multiplied by 5 yards. And then the height of that triangle is labeled here as 1.5. And that's 1.5 yards. Now notice if we stopped here, that would give us the area of one of those triangles. Yards times yards, that's yards squared. But we don't want just yards squared, we want yards cubed because we're dealing with the volume. So now multiplying by the overall length of our figure of 4 yards. So now it's just a matter of typing this in on your calculator or multiplying it out in your head. 1/2 times 4 yards is going to give us 2 yards. 1.5 times that 5 yards is going to give us 7.5. So 7.5 times 2 is going to be 15. And remember, our units, that's yards cubed. So 15 yards cubed is our volume for number 1. Let's move on to number 2. Now in number 2, we don't have a prism because the bases are not the same. We have a triangular base here, but that's not replicated anywhere else in our figure. We have one single base, and then the other sides connect to form a pyramid. So if we're calculating the volume of a pyramid, we're going to use that pyramid formula, which the volume for a pyramid is 1/3 the area of the base times the height. So similarly to how we did number 1, where we took the area of the base and multiplied it by the height, for a pyramid, it's 1/3 the area of the base times the height. So just slightly different. So let's go ahead and calculate that now. Well, what's our base? For our pyramid, our base is the side, and it's a triangle where the length of that is 3 and the height of it is 4. So we have 1/3 times the area of a triangle is 1/2 its base, which we said was 3, and that's miles, times its height of 4 miles. So now that we have the area of our base, we need to multiply that by the overall height of our figure, which is labeled as 5 miles. So working this out, we can actually multiply 1/3 by 3 that becomes a 1, and then 1/2 times 4 becomes a 2. So we're left with 2 miles times 5 miles times 1 mile. 1 times 2 times 5 is 10, so that's a total of 10 miles, and that miles is cubed because we have miles times miles times miles. So 10 miles cubed is the volume for number 2. So far, let's review. We've talked about the volume of a prism, which is the area of the base times the height. And we've also now talked about the volume of a pyramid, which is 1/3 the area of the base times the height. Let's move on to our next figure. In number 3, what do we have? We have another pyramid. So what's our volume going to be? That's going to be 1/3 the area of the base times the overall height of our figure. So in this case, what is our base? You can see that our base is a square. 3 yards by 3 yards, all the sides are the same, that's a square. And the area of a square, or the area of the rectangle, is just the length times the width. So, filling this in, we're going to have 1/3. The area of our base is 3 yards times 3 yards, and that gets multiplied by the overall height of our figure, which is 5 yards. So let's multiply this out. We have 1/3 times the area of our base. 3 yards times 3 yards is 9 yards squared, and that's multiplied by 5 yards, our height. Now, I know that 9 is divisible by 3, so when we multiply 1/3 by 9, we get 3. So we have 3 yards squared times 5 yards, which equals 15 yards cubed, and that's the volume for number 3. Let's move on to number 4. In number 4, we have a new figure. It looks similar to a pyramid in that we have one single base. However, the only other side wraps around the figure without any edges. So this is a cone. How do we calculate the volume of a cone? It's very similar to a pyramid. It's going to be equal to 1/3 the area of the base times the height of the overall figure. So essentially the same exact formula. It's just a little trickier because our area of a base, we need to calculate the area of a circle. Do you remember what that is? That's pi r squared. I'll write it over here. Pi r squared is the area of a circle. So filling this in, we're going to have 1/3 times the area of our circular base is going to be pi times r squared. But what is r? R, remember, is the radius, which it gives us here the diameter because we're going all the way across. The radius, r, is half of that diameter. So if the full diameter is 2 kilometers, we want half of that. So 2 divided by 2, those 2 kilometers, which is our diameter, cut that in half to get our radius, that's going to be 1. Again, that's because the radius equals the diameter over 2, or 1/2 the diameter, and because we're given the diameter, our radius is going to be 2 kilometers divided by 2, which is 1 kilometer. So we have pi times 1 kilometer, that quantity squared, all multiplied by our height of 3 kilometers. So let's calculate this out. The area of our base, pi times r squared, well, our radius is 1 kilometer, and 1 kilometer squared is just 1 squared times kilometer squared, which is 1 kilometer squared. So we have 1/3 times pi times 1 kilometer squared, because 1 squared is just 1, so we just change our label to 1 kilometer squared, and that's multiplied by 3 kilometers. So simplifying this down, 1/3 times 3 kilometers is just going to be 1 kilometer. And 1 kilometer times pi times 1 kilometer squared is just 1 times pi times kilometers cubed, which is pi kilometers cubed. However, we need to round to the nearest decimal, and pi is equal to 3.14 and so on. Taking that 4 and rounding it to the nearest tenth, that's 3.1. So our volume in number 4 is 3.1 kilometers cubed. Let's move on to number 5. In number 5, what do we have? Essentially, we have something that resembles a prism. However, this figure has a particular name because we have a circular base. So just as the previous one had that circular base and had a special name as a cone, this has a special name. It's a cylinder. But we're calculating volume the same way we would a prism. Volume is going to be equal to the area of the base times the overall height of our figure. It's just that the area of our base, we have to deal with the area of a circle. So let's write this out. The area of a circle we know is pi r squared, and that gets multiplied by our height. So area of the base times the height of our overall figure, which again, they're giving us not the radius r, but our diameter d. We know that r is equal to the diameter divided by 2, or half of that diameter. So r in this case is 4 inches divided by 2, which is 2 inches. So filling out the area of our base, we have pi times r squared, which is 2 inches squared, and that gets multiplied by the height of our figure, which is 3 inches. Now let's finish calculating this out. 2 inches squared, 2 squared is 4, so we have 4 inches squared times pi times our 3 inches. And remember, we're multiplying, so the order in which I put these doesn't matter. 4 inches squared times 3 inches, 4 times 3, that's 12, and that'll be 12 inches cubed times pi. Remember, pi is 3.14, so multiplying that by 12, we get approximately 37.7 inches cubed. That's our volume in number 5. Let's move on to number 6. Number 6 is actually just a cube, like a prism, but our base is a square. But notice, even the sides are squares. So this figure, regardless of how we turn it, has the same side every single way. And the volume of a cube is equal to the length times the width, which would be the area of a single base, but then you have to multiply it by the height of the figure. And in this case, everything is 2. So we're going to get 2 meters times 2 meters times 2 meters. 2 times 2 is 4. 4 times 2 is 8. So this is 8 meters cubed for our volume in number 6. In number 7, what do we have? We have a triangular prism. Remember, the volume for that is going to be the area of the base times the overall height of our figure, which our base is a triangle. So we need to first calculate the area of this triangle and then multiply it by our height, which we can see is 3 yards. So let's go ahead and calculate this out now. The area of our base is 1/2 times the length of the base of the rectangle, which is 6 yards, times the overall height of that triangle, which is 2.5 yards. So there is the area of the base. If we were to calculate that out, we'd get this area that I just shaded in. But this area of the base gets multiplied by the overall height of our figure, which we already stated was 3 yards. Calculating this out, 1/2 times 6 yards is 3 yards. 3 yards times 3 yards is 9 yards, and that's yards squared. And then 9 yards squared times 2.5 yards is 22.5. So our solution is 22.5 yards cubed for number 7. And again, I'm just multiplying all these numbers together, keeping track of my units. Moving on to number 8, what kind of figure do we have? We have a pyramid. So we know the volume of a pyramid is going to be 1/3 the area of the base times the overall height of the figure. So calculating the area of the base first, we can see that the base itself is a rectangle, and the area of a rectangle is just length times width. So we're going to have 1/3 times the area of the base, length times width. It's 2 inches times 1 inch. And that gets multiplied by the overall height of our pyramid, which is 1 inch. Multiplying all of this out, we have 1/3 times 2 inches times 1 inch times 1 inch is going to be 2 inches cubed. So overall, this is 2/3 inches cubed. 2 divided by 3 is approximately 0.6 repeating. So when we round that, we're going to get 0.7, and that's inches cubed. Let's move on to our next page, number 9. Number 9, what do we have? A triangular prism. So you can see that our base is indeed a triangle, and it's a prism. So that's going to be the area of our base times our height gives us our volume. So the area of our base is going to be 1/2 times the length of the base times the height of the base, which is 12 centimeters by 9 centimeters. So 1/2 times 12 centimeters times 9 centimeters, that's the area of a triangle, 1/2 base times height, and that gets multiplied by the overall height of our figure to give us volume, which is this 19 centimeters. Now you may be asking, why didn't I use 15 centimeters at all? Take a look at our triangle again. The length of the base of our triangle is this 12, and the height of it is this 9 centimeters. The height is always perpendicular at a right angle to the base. So once you find that right angle, you know your base and your height. You don't need to worry about that other length to the triangle. So let's calculate this out. 1/2 times 12 centimeters is 6 centimeters, and 6 centimeters times 9 centimeters is 54 centimeters squared. So that's the area of our triangular base, and we multiply that by our height of 19 centimeters. 54 times 19 is 1,026, and that's going to be centimeters cubed. Don't forget your units when talking about area or volume. On to number 10, we have another prism. In this case, it's a rectangular prism where you can see here is one base, and the same base is on this side, which is also a rectangle. You could also see the base as this side, and extending it, we have our other base on the other side, or even with the other two sides going this way, having this as our base, extending that down, and you see this. So there's lots of ways to look at a rectangular prism. Just keep track of what you're using as your base so you can calculate the area of that, and then what you're using as your height. So I'm going to do what I originally boxed in, which was the smallest side here. So using this as my base, I can see that the area is going to be the length times the width. So I'm going to have my area of my base as 4 meters times 10 meters, and then the overall height of my figure then is the length of this side here, which is 17 meters. Calculating this out, my area of my base, 4 meters times 10 meters is 40 meters squared, and that gets multiplied by 17 meters. 40 times 17 is 680, so this is going to be equal to 680 meters cubed as the volume of my rectangular prism. Moving on to number 11, we have a pyramid. What's the formula for that volume? 1/3 the area of the base times the height. So our base, you can see, is a rectangle for the case of this pyramid. So we're going to do 1/3 that area. So 1/3 the area of our base, which is length times width, 15 meters times 12 meters. And that gets multiplied by the overall height, which is labeled here as 20 meters. Simplifying this down, since it's all multiplication, 1/3 of 15 meters is just going to be 5 meters. So I'll have 5 meters times 12 meters times 20 meters. 5 meters times 12 meters is 60 meters squared. And that gets multiplied by 20 meters. 60 times 20 is 1,200. So this equals 1,200 meters cubed. That's the volume of my pyramid in number 11. In number 12, we don't have a pyramid. Instead, we have a prism. So let's identify that base. Well, we can see the base is a triangle. So for a prism, we do the area of the base times the height. Since our base is a triangle, the area of a triangle is 1/2 times the base of our triangle times the height of our triangle, which, remember, as stated before, the height and the base of a triangle are perpendicular. So you can see here is my right angle. So this side and this side identify my base and my height. So my height is my 9.3 and my base is this length here, which is labeled in our top triangle as 19 meters. So I have 1/2 times 9.3 meters times 19 meters, and that gets all multiplied by the overall height, which is 15 meters. So in number 12, you can see that 18 and 10 didn't even get used. They're just the other sides of my triangle that weren't my base or my height when talking about the area of my triangular base. So they were unnecessary. But let's continue on with this calculation. 1/2 times 9.3 times 19 times 15, entering that all in to a calculator just to make the math a little bit easier, we're going to get the area of this prism as 1,325.25, but rounded to the nearest tenth, that's rounding up to 0.3, and this is meters cubed, remembering our units. Again, all I did here was multiply out each of my numbers and cube my label, making sure to round to that nearest tenth. In number 13, we have that special figure. Since we have a base that's a circle and it's identical on two sides of our figure, this is going to be a cylinder, similar to a prism, but just with a round base. How do we calculate the volume? It's just the area of the base times the height, where our area for our base is the area of a circle. It gives us the diameter, the whole length, but we want half of that. What is the radius? Well, if we divide this 40 miles by 2, that's going to give us 20 miles for our radius. So calculating the area of that circular base, we're going to have pi times 20 miles, that quantity is squared, but then that area of the base gets multiplied by the overall height of 11 miles. Calculating this out, 20 miles squared is 20 times 20, which is 400 miles squared, and we're multiplying that by 11. So we have 4,400 miles cubed times pi. Multiplying that by pi, that 3.14159,265, and so on. Lots of times there's a button on your calculator for pi, but if not, write out pi to a few decimal places. Since this number is so large, we want to make sure we're rounding to that nearest tenth, and we want to be able to capture that. So this is going to be equal to 13,823.00. So rounding to the nearest tenth, that's just 0.0, which is 13,823, and that's miles cubed. So if you were to just multiply that 4,400 by 3.14, you would only be at about 13,816 miles cubed. That's because you didn't do enough decimals on this pi when multiplying. The more decimals you use, the more accurate of an answer you get. Let's move on to number 14. Number 14, similar to 13, another cylinder. So we're going to have pi r squared, which if our diameter is 14, our radius, half of that would be 7. So pi times 7 yards squared, all multiplied by our height of our overall figure, which is 11 yards. Calculating this out, 7 times 7 is 49. So we have pi times 49 yards squared times 11 yards. 49 times 11 is going to give us 539. So that's 539 yards cubed times pi. Multiplying that, making sure to include enough decimal points, we're going to get a volume of 1,693.31 roughly, which rounds to 0.3. So 1,693.3, and that's yards cubed. Moving on to number 15, we have a rectangular prism. So let's pick one side to be our base, which I'm going to choose this side here. That means that my height will be this 19. So the volume for a rectangular prism, area of a base times the height, that's going to be 4 inches. The length times the width, 11 inches, times the height of 19 inches. That is going to give me my volume V. So 4 times 11 is 44. Multiplying that by 19 is 836. So this is 836 inches cubed for our volume in number 15. In number 16, what do we got? We have a pyramid. What's the volume for a pyramid? 1/3 the area of the base times the overall height. So that's going to be 1/3 times the area of our base is going to be, well, it's a rectangle, so length times width, which is 17 miles, times 18 miles. There's the area of our base. Multiply that by our height of 17. And then we're taking 1/3 of that. So this is going to be equal to 1/3 of 18 miles is 6 miles. So I'll write that as 6 miles times 17 miles times 17 miles. Typing those all into our calculator, 6 times 17 times 17 gives us 1,734, and that's miles cubed for our volume. Again, all I did here was take the 1/3 and apply it to 18 at the start, since I knew that 3 went into 18 evenly, just to make it a little bit easier when I quickly entered it in on my calculator. For now, let's move on to number 17. Now in number 17, we no longer have our figure, but we're told exactly what it is. It's a cylinder. How do we calculate the volume of a cylinder? That's going to be the area of the base times the height, where, remember, that special cylinder, the area is going to be involving a circle, and it gives us our radius. So we just need to fill everything in. Area of the base is pi r squared, so that's pi times 3 centimeters squared. That's the area of our circle, which is our base, and we multiply all that by our height, which is also given as 7 centimeters. 3 centimeters squared is 3 centimeters times 3 centimeters, which is 9, with a label of centimeters squared. So we have pi times 9 centimeters squared, because I already applied the squared to our 3, and that gets multiplied by 7 centimeters. 9 times 7 is 63, so we have pi times 63 centimeters cubed. Doing that out on our calculator so that we can round to the nearest tenth, 63 times 3.1415 is going to give us 197 and approximately 0.9. So 197.9 centimeters cubed is our solution for number 17. Again, that's 197.9 centimeters cubed for our volume. For number 18, we're given that it's a cone. What's so special about a cone? It has that circular base, but the volume is calculated similarly to a pyramid. It's 1/3 times the area of a base times the height of the figure. So let's calculate that out. We're going to have 1/3 times the area of our base. We know it's a circular base since it's a cone, and they give us the diameter of 20 centimeters. That means that our radius is going to be equal to 20 centimeters divided by 2, which is 10 centimeters. So the area of the base is pi times 10 centimeters, and that entire quantity squared. So that's 10 squared and centimeters squared. Pi r squared, and that gets multiplied by our height of 20 centimeters. Calculating this out, we're going to have 1/3 times pi times 10 squared is 100, so that's 100 centimeters squared, and that gets multiplied by 20 centimeters. Simplifying a little further, 100 times 20 is going to be 2,000, so we're going to have 1/3 times pi times 2,000 centimeters cubed. So 2,000 divided by 3 is 666.6 repeating, and if we multiply that by pi, 3.14159, that's going to give us approximately 2,094.39, so rounding to the nearest tenth, 0.4, and that's centimeters cubed. Let's move on to number 19. For number 19, it tells us we have another what? Another cone. Circular base, and it's a cone as opposed to a cylinder, so we need to multiply the area of the base and the height by 1/3. So volume equals 1/3 pi r squared times h. Let's fill all of this in. 1/3 times pi times r squared. Our radius is half of 14 since we're given the diameter, which is 7, and 7 squared is going to be 49. So 49 yards squared times our height of 14 yards. And again, in my head, I already calculated out this r squared. R was 7, 7 squared is 49, so we have 49 yards squared. Now, we'll have 1/3 times pi times 49 times 14 is 686, and that's yards cubed. Simplifying further, if we take that number and divide it by 3, we get 228.6 repeating. Multiply that by our pi of 3.14159, and we get 718.4. So 718 4/10 yards cubed. Finally, our last problem on this worksheet, number 20. If you stuck with me so far, go ahead and click that thumbs up button. Let's finish this out though. We have a rectangular prism. So a prism, area of the base times the height. It measures 10 by 7 and it's 12 meters tall. Length times width gives us the area of the base, and we multiply that by the height. So we're going to have 10 meters times 7 meters times 12 meters, and that's going to be our volume. So 10 times 7 times 12 gives us a total of 840. So that's 840 meters cubed. That's our final solution on this worksheet. If you have any questions, please feel free to leave them in the comments below. And as always, don't forget to like, subscribe, and share. All likes and subscriptions are greatly appreciated.